So today we will see the non-recursive approach for post-order traversal. So like let's say here we'll give a heading non-recursive post-order traversal. Non-recursive post-order. Let us take a simple example of tree and then we'll see how it should work. So I'll draw a simple tree here. So let us assume here I have drawn a tree. I'll put some values here. A, B, C, D, E, F, G and H. Now sequence for post order traversal is left, right and parent. Now look at here. When I'm traversing a tree, first of all I'll go to the leftmost part. Right. So I have to use one while loop to go to its leftmost part. Now once it goes to leftmost part and its left part is null, the root is null, then what we'll do, we'll take the D. Let's say it has some right child. Let's say X. So then I'll go to the right, I'll take X. Okay. But if doesn't have left and right child, then we are going to take this node D itself. Right. So for printing that node, what are the two things? First of all, I supposed to go to the left of it. Then I have to check it for a right child. So in the two conditions, I'll visit the parent node. The first condition is if its right child is null, or second thing is I am coming from right node to the parent. Very important, right? So first of all, I'll display here D. Now, who is the parent of D? B is the parent of D. Okay, so I'll visit D, then I'll visit its right child E. Very important over here. Okay, so I'll visit E. Now I am coming from right child to the parent, then I will take B. Then I'm at A, but I'm supposed to visit the right part of A. So I'll go to C. C doesn't have left child. I'll go to right of C. There is F. F has a left part G. G doesn't have left part, doesn't have right part. So I'll print here G. Then I'll go to F, but F ka right is there. So I'll take H. Then I am going from H to F. So I am printing parent only when I am going from its right side towards the parent. So I'll take F, then C and then A. Right. So if you look at this algorithm, we'll see. I'll remove this part here. Let us try to construct now algorithm for non-recursive post-order traversal. So here I'll write void post-order. I am passing here a node. We can pass root or we can simply say it as T. Okay. Now I need a one more reference node because to check that whether I am going from right child towards the parent or left child towards the parent. So I need the previously visited node should be a right node. So I'll take here node previous. Okay. Now I have to start it. So I'll use a do while loop. I'll just continue till the stack is not empty. So first of all, there is nothing in the stack. So I'll make use of a do while loop. So I'll put this in do. Now what is the first thing that we did here? First of all, we go to the leftmost part of the tree, right? So while we can say here while that t is not equal to null, what we supposed to do? We're supposed to push that t onto stack, and we go to the left of t. So we'll say t is equal to t of left. I'll explain also afterwards how it works for the stack. Okay. Now I come at the d. Okay, so d doesn't have no left child. The left child is null. So after that, what we'll do now, as currently temporarily t is null, so again I have to come back to d. Okay. So next step, while it's just a condition to enter inside the while loop while t is null and the stack is not empty. Not empty stack. Because if t is not null, that means there is something in the left, and again I have to go to the left part. So that's why this condition will say that t is the leftmost part and there is something in the stack is not empty. Then what we'll do now, so in the stack currently we have pushed A, we have pushed B, we have pushed D, right? And then T becomes null. So I have to take now top of the stack. I have to process with D. So what I'll do now, I'll take here new T is equal to top of the stack. So this will return me D. Okay. Now there are two things. I will print a D. First thing is if D ka right is null or previously visited node is the right node of D. In these two cases only I'll print D, otherwise I'll go to the right of D. That means there is a right child. So there are two cases. If I'm going from right part to D, I'll display it. Otherwise I'm supposed to go to the right of D. So we'll take these two if cases. This if in the while loop, if T of right is null, if T ka right is null, or we are coming from it's T of right, or if right is not null, then previously visited node is our right. Okay. So T of right is previous. So I'll write it clearly here. Previous node. Okay. Now currently both are null. So we are entering into if loop. What we'll do here, we'll print the node, printf, say %c T of data. So now I have printed D. Okay. Now I'll pop it from the stack. Then I will mark now previously visited, now currently visited node is D. Before proceeding further, we'll mark here previous is equal to current visited node. Okay. And then here we will make T as null. Because again we want to enter into the while. So this completes if here. Now for else part, I'll remove this tree here. I'll write else part here. Afterwards again, I'll draw the tree. So else, if we are not visited right child or right child is not null, else what we supposed to do? t is equal to t of right. We're supposed to go to the right path of it. Okay. So here completes our while loop. If else, then here completes the while loop, and then here completes the do while loop, and that will go till while not empty stack. Okay. And then completes the main function. Oh, so you note down these points. Just remember this condition here. While t is equal to null and stack is not empty. Okay. So this is why we are doing here t is equal to null, because I am just making sure before actually taking from the top I have visited the leftmost node of the tree. That's why I am making it null. Now here I am making it t as null. Why? Because again I have to repeat into the same while loop, because I have visited the right child and I want to take out the next value from the stack. Here if there is something in the right of the tree, then what I have to do, again I suppose to repeat the same process, go to the leftmost part of the right subtree. Okay, so that's why this plays a very important role over here. Okay, so you note down this. I'll draw another tree and then we'll see how it works basically using the stack. I'll just wait for 2 minutes. Okay, so we will solve this using taking a tree example. So I'll draw some simple tree over here. So let us say this is a particular tree which I'll draw here. Okay, draw this also. And I'll put values here. Say A, B, C, D, E, F, G, H. Okay, so now I'll draw a stack because we are using stack here. So let's say I'll draw the stack. Now let us proceed. So we are passing the root. So root is A. While this T is not null, we are pushing that into the stack. So I'll push A. I'll come at B. I'll push B. I'll come at D. I'll push D. I'll come at G. I'll push G. Now after G of left is null. So this while loop will break here. This while loop will break here. Now we'll come at to the second while loop. While T is null, yes, T is null and the stack is not empty. So we'll take top of the stack. Currently top of the stack is G. Okay. Then does G of right is null? Yes. G of right is equal to previous. Yes, previous is here. We are supposed to initialize this previous as null. Forget here. Okay. So now both are satisfying. So what we'll do? We'll print G. So I print here G. Now we'll pop G from the stack. We remove G from the stack. We'll mark previous is equal to G. We'll mark here previous is equal to G, and we'll make T as null. Okay. Now again we will come in the while loop. Yes. Does T is null? Yes. Does stack is not empty? Yes. Make D as the top of the stack. So currently at the top there is D. Okay, that is named as T now. Does T of right is null? Does D of right is null? No. So this if loop will not execute. Will come into else loop. T is equal to T of right. So now currently will come at H over here. Okay. Now H means this is pointed by T. Does T is equal to null? No. So this while loop will break, and again we will come into outer while loop. Stack is empty? No. So we'll come at do. While T is not null, we are going to the left of T. So currently our T is at H. We are pushing H onto top of stack. Now the left of H is null. So this will break here. This T is null. Stack is not empty. Now take T is equal to top. So currently at the top there is H. Then we'll check, does T of right, does H of right is null? Yes, H of right is null. So we will print H. We will remove H from the top. We'll mark previous is equal to H over here. And then we'll make T is equal to null. Again we'll continue in this while loop. Does T is null? Yes, T is equal to null. Again we'll come here. We'll mark T is equal to now new top. So currently at the top there is D. So we will mark T as D. So we are at now D here. Okay. So does D of right is null? No. Does D of right is equal to previous? Yes. Previous is H and D of right is H. So this condition holds true here. That means we have visited left of D. We have visited right of D, and now we are coming towards D. So again we'll enter in the if loop. We'll print here D. Then we'll mark previous equal to D. So here now previous will be D. And then we'll make T as null. Again we'll continue in the same while loop. Does T is equal to null? Yes. Stack is not empty. Now T is equal to top. So currently top of stack is B. So we are at B. Does B of right is null? Yes, B of right is null here. So we'll come here. We will print B. We'll take away B from the top. We'll mark previous as B here. And we'll make T is equal to null. So only in the stack there is only value A. Now let's go next. Again we'll come in the while loop. T is null. Yes, T is null. We'll take T is equal to top. So top is A. So now T is equal to A. Does T of right is null? No. T of right is, there is complete subtree here. T of right. Does T of right is equal to previous? That means A of right is C, but our previous is B. So this condition is also not hold true. So we'll come at the else loop, and here T is equal to T of right. So now T will come at C. So at this point currently in the stack here, so our stack will look like for this condition. Currently in the stack now only A is there. T is at C. So again else loop we are here. Now T is C. T is not null. So this while loop will break. We'll come at outer while loop. The stack is empty. No, there is A in the stack. So we'll come in the do. While T is not null, push T. So we are pushing C onto top of stack. T is equal to T of left. Now we are at E. We are pushing E onto top of stack here. Okay, now E of left is null, so this while loop will break. We'll come here. Does T is null? Yes, stack is not empty. Now make T is equal to top. So currently top is E. So T is pointing out to E. Does E of right is null? Yes, E of right is null. So we are displaying E over here. Then we are removing E from the top of stack. We are marking E as a previous and we are making T as null. So again we'll come in the while loop. T is null. Yes. Take out next top. So currently at the top there is C. We are marking it as C. Does C of right is null? No. Does C of right is previous? So previous is E, which is, and now currently it is F. So this will not hold. True. Then else go to C of right. So we are going at F. So our T is at F. Does T is null? No, because T is pointing out to F. So we'll come at this while loop. While T is not null, push T onto top of stack. So there is F. So we will push F onto top of stack. So currently stack will be F, C, A. Okay. Then F of left is null. So this while loop will break here. Then we'll come here. So T is null. Yes, because F of left is null. We'll take T is equal to top of stack. So currently at the top there is F. Does F of right is null? Yes, F of right is null here. So we'll print F here. We'll delete F, pop F from the stack. We'll mark previous as F. Then we'll make T as null. So again we'll in the while loop. While T is null, yes, and the stack is not empty. Make T is equal to new top. So new top is C. Does C of right is null? No, C of right has F here. But C of right is previous. So C of right is F and previous is also F. So this holds true. We'll print C. We'll remove C from the top of the stack. We'll mark previous as C. Now currently C is previous. And we'll make T as null. So this if else. Again we'll come at the outer while loop. While T is equal to null. Yes, because we made here T as a null and stack is not empty. There is A in the top of stack. Then T is equal to top of A. So now currently T is pointing out to A. Does T of right is null? Does A of right is null? No. But A of right is previous because previous is C and A of right is C. So this holds true. We'll print here A. We'll pop A from the stack. So our stack becomes empty. We'll mark previous as a T. That is previous is A and T is null. Now we'll come again in this while loop. While T is null, yes, T is null because we made here as null. But here stack is empty. So this condition will false here. Again we'll come at the while loop. While does the stack is not empty? No, stack is empty. So this condition also will not work and here terminates our algorithm. So here we get GHDBEFCA as basically our post order traversal on the given tree. Okay, so this is very important logic. We are using here previous to make sure that whenever I am approaching a parent, either my parent ka right should be null or I have visited its right child of the parent and then I am approaching the parent. So this is very important point that we should have to be aware of. Okay, so in case of the post order traversal here, two times we are visiting the parent. Once is going towards the right child, left child, and from right child towards the parent. Okay, this is about non-recursive post order traversal.